Okay, in this video I'll be going through thermal properties of metal, tutorial question 3. Okay, a 10 kg block of ice, that means I have the mass of ice, right? It has a temperature of minus 10 degrees Celsius. Now the block absorbs 4.11 megajoules of energy into its internal store. That means 4.11 megajoules. 4.11 times 10 to the power of 6 joules of energy is being transferred into its internal store. Now, what's the final temperature of the liquid water? So maybe I'll let the final temperature be X. So now it is very useful to draw a heating curve. So the ice started off from minus 10 degrees. So this is my axis, my temperature versus time. So at minus 10 degrees, if I transfer energy to the internal store of the ice, the temperature will increase. So it will increase until it reaches 0 degrees, right? Then after that, it will start to melt. So only when all the ice has melted, then the temperature of the water will increase. So this will be my X, and it will occur at a certain time. Okay, so now I need to determine the final temperature, and if I were to provide more energy or less energy, okay, if I provide more energy, then the temperature will be higher than X. If I provide less energy, it will be less than X. Okay, so there will be this temperature of the liquid water called X when I just supply 4.11 megajoules. So there will be 3 stages of calculation. The first one is when the temperature of the ice increases. When the temperature of ice changes. So I'll be using sea ice. Okay. Then after the temperature increases until 0 degrees, the ice will start to melt. So over here, I'll be using specific latent heat of fusion. Okay, which is when the solid changes to liquid. Once all the ice has melted to become liquid water, then I'll be using CW. Okay, so all the values are actually written up there. I'll be filling in them. Okay, so this will be the 3 values that we'll be filling in that we need to know. So firstly is the specific heat capacity of ice. Why do we use it here? Because this is the ice that is increasing its temperature. Okay, the next part is specific latent heat of fusion, which is actually the energy needed for the ice to change state into liquid at a constant temperature. And lastly, we have our specific heat capacity of water. So there will be 3 stages, therefore 3 calculations. The first calculation will be to calculate the energy required for this 10 kg of ice to increase its temperature from minus 10 to 0 degrees. So I'll be using this formula whereby I'll be using the mass of ice followed by the specific heat capacity of ice, and this will be my change in temperature. So I'll get 210,000 joules. Okay, the next calculation will be for the to calculate the energy needed to melt the ice. Okay, by using the formula Q equals to M latent heat of fusion, the mass is 10, and this is my specific latent heat of fusion. Okay, so I'll be getting this amount of energy. So lastly, I'll calculate the amount of energy needed to increase the temperature of the water to X. Okay, so this is the last stage of calculation whereby I'm calculating the amount of energy needed to increase the temperature of the water to X. So I'll be using Q equals to MC. I'm using CW and using the higher temperature of X minus initial temperature of 0. Okay, so I'll be getting in terms of X 42000 X joules. So all these 3 stages of energy will be added up together, and it will be a total of 4.11 times 10 to the power of 6 joules. Okay, so if I were to do my calculation, it will look like this. So I form the equation 4.11 times 10 to the power of 6 joules equals to the first stage plus second stage when it's melting, and lastly, it contains the unknown of x for the last stage whereby the temperature of the water increases from 0 all the way to x. So by forming this equation, I should then be able to solve for x. The answer will be, okay, by shifting this and this over and being subtracted, I'll get 600,000, and this will be equals to 42000x. So therefore my x will be 14.3 degrees Celsius. Okay, and that will be the temperature of the water.